Question 35. The table below shows the body temperature in degrees Celsius of a desert spiny lizard at various air temperatures in degrees Celsius. Part A, tell whether the data can be modeled by a linear function, an exponential function, or a quadratic function. Explain your reasoning. Okay, I decided on this one that I was going to go ahead and do a scatter plot. So I'm just going to go ahead and make a scatter plot for it. And so hopefully you did that as well. Please make sure if you did that, we would label the x-axis the air temp, and the y-axis would be our body temp. And then when I did that and did my scatter plot, it turned out to be a nice straight line. So I would say the data models a linear function because the y values are increasing at a constant rate. I also might say the data when graphed forms a straight line. I could say anything as long as you are able to tell why it's a linear function. Please notice that I used a complete sentence in my explanation. Okay, the next one, it says to write an equation for the function. Well, I know that if it's a line, we're going to use y equals mx plus b. And when I find a line, I need 2 points so that I can find the slope. So we can pick any 2 points in the line. I'm going to pick this one and this one, not necessarily the same ones that you picked. All right, finding the slope is going to be y2 minus y1. So 34.46 minus 33.78 over x2 minus x1, so 29 minus 27. And when I do that, I'll get 0.68 divided by 2, which is equal to 0.34. So my slope is 0.34. Now I'm going to use one of those circled points. I'm actually going to use the 27 to do this next part. So I'm going to get 33.78 is equal to 0.34 times the x, which is 27, plus b. So I plugged in my m, my x, and my y so that I can find my b. So this is going to give me 33.78 is equal to 9.18 plus b. And then I'm going to subtract 9.18 from both sides. And when I do that, I'm going to get b is equal to 24.6. So from here, my equation is going to be y equals 0.34x plus 24.6. So that's the equation of my function. All right, and then part C, use your equation to find the body temperature of the lizard if the air temperature is 50 degrees Celsius. So now I'm going to use my equation. 0.34x is the air temperature, and so I'm going to put 50 in for my x and plus 24.6. When I do that, I come out with 41.6, and I need to decide how am I measuring it. If I'm talking about body temperature, it says it's in degrees Celsius, so my units would be degrees Celsius. All right, number 36. The pesticide DDT was widely used until it was banned because it is toxic to a wide range of animals and aquatic life and is suspected to cause cancer. DDT takes a long time to disintegrate after it is sprayed. The chart below shows the amount of 100 grams of DDT remaining in the environment after a certain number of years. All right, does a linear, exponential, or quadratic function best model the situation? Explain. All right, I chose to, on this one as well, make a scatter plot. On my x-axis is the years, and on my y-axis is the grams of DDT. And when I did this one, I got a scatter plot that was modeling an exponential function. So I would say the data models an exponential function. And on this one, I'm just going to say because the y values are decreasing rapidly, and you could have a different reason as long as you're able to tell. You could say something about when I drew a scatter plot, I found that the data was forming an exponential curve. That would be fine as well. Okay, create an appropriate model for the situation. We know exponential is y equals a times b to the x, right? Usually a lot of times we can find the b just by dividing, but since the x values are not going by ones, we can't do that. So in this one, we actually have to pick 2 points again. So the 2 points that I'm going to pick, we have our choice a little bit here, but I am going to pick the points 15, let's see, I want to pick 66, and I think I'll pick 1550. So I like to start with the second point first. It's a little bit easier, so I'm going to have 6 equals a times b to the 60, and then my second equation is going to be 50 equals a times b to the 15, and then remember in this step we're actually going to divide. So 6 divided by 50 will give me 0.12, and then the a's cancel out. The b's, I get to subtract the exponents. I'm going to get b to the 45. Okay, to get rid of the 45th power, we're going to actually take the 45th root. So we're going to take the 45th root of 0.12, and when we do that, we should get b is equal to 0.9534. All right, so now I'm going to go back into either one of these equations. I'm going to prefer to go back into the 6th one. It doesn't really matter. So I'm going to have 6 equals a times, I'm going to put my b in now, 0.9534 to the 45th. And then from here to get the, wait, that was a 60, sorry, my bad. Okay, so going back into that, there was a 60 there. And then from here to get the a by itself, I'll just divide both sides by 0.9534 to the 60th. And when I do that, I will get an a value of 105.11. So the equation is y equals 105.11 times 0.9534 to the x. That's the exponential model. It says to use your model to determine how many grams of DDT will remain 120 years after it is sprayed. So I just need to put the 120 in place of the x. So I'm going to show that 105.11 times 0.9534 to the 120th power, and when I do that I should end up getting 0.343, and my label will be grams. Okay, 37. During a halftime show, a baton twirler releases her baton into the air. The path that follows is shown in the table below. Tell whether the data can be modeled by a linear function, an exponential function, or a quadratic function. Okay, once again, I went to my calculator and made a scatter plot, so I'd suggest that you do that as well. So this was the time, and this was the height of the baton, and when I did that, I got something that looked like that. It definitely models, looks like a quadratic function, it looks like a parabola. This time I'll change my reason a little bit. I'm going to say the data is quadratic because the scatter plot is in the shape of a parabola. And again, you could say something else, but that's what I'm going to do. Once again, notice I did use a complete sentence to do that. Okay, write an equation for the function. All right, we know if it's quadratic, it's going to be y equals a parentheses x minus h squared plus k. And then I know that I need to look for the vertex, so if I'm looking for these points right here, I notice that it reaches its high point right here, and then it ends up going back down again. So 348 is the vertex. So this is going to be y equals a x minus 3 squared plus 48. So I have my vertex in there now. The second thing that we want to do is pick a point, and I can pick any point that I want. I'm going to choose to pick 243. So I'll put the 43 in for the y and the 2 in for the x. So I'm going to have 43 equals a 2 minus 3 squared plus 48. So I'll have 43 equals 2 minus 3 is negative 1. Negative 1 squared is 1. So I'm going to have 1a, or just a, plus 48. And now I get to solve for a. So I'm going to subtract 48 from both sides, and I'm going to get a equals negative 5. So the equation of my function is going to be y equals negative 5 parentheses x minus 3 squared plus 48. And remember, on all these problems, you can always type your, and I actually did this when I did this problem, I actually typed this into my calculator and made sure that it did follow the shape, and it definitely did, so I knew I was on the right track with this. Okay, part C is a little bit different. It says, how much time does the twirler have if she plans to catch the baton on its way down at a height of 5 feet? Well, if I look up here, we let the x be the time and we let the y be the feet, so I'm actually looking for a y value of 5. So I did Control T to look at the table, and I noticed that at 5 seconds the height was 28, and at 6 seconds the height was 3. So I know that it has to be pretty close to 6, and so I just thought, okay, what if it was 5.9? So then I actually plugged 5.9 into my equation. And when I plugged 5.9 into my equation, it was still a little bit big. So then I plugged in 5.91, I plugged in 5.92, and when I plugged in 5.93, that got me closest to 5. It ended up being like 5.0 something. So I actually did a little bit of investigation to get there. So how much time does the twirler have? She has 5.93 seconds. So that would be my answer for that part.